Hey guys, it's Finn. In this video, I'm going to start coding the new network library. But before I do that, I need to show you something that I forgot in the last video, and it's about the layer sizes. Like in the last tutorial, we had for each layer we had a fixed size. The size will be fixed in this tutorial as well. Like there's no layer is going to change over time in their size or whatever. But what we had in the last time, we had only one array with output neons. In this video, we are going to deal with three-dimensional output neons, and the reason for that is that there might be layers that where the input must be like a two-dimensional array. For example, let's take an image. Usually, an image is a two-dimensional ordered array. The data in it does make sense the way it is ordered in the 2D array, and it might even be three-dimensional if you consider RGB values. And therefore, they're like layer types. I'm not going to talk about them yet, but for example, convolutional layers, they need to have three-dimensional inputs. Later on, if we're going to implement the standard fully connected layer, we will break that down to only one dimension. But so we are not going to have an input size and an output size of our layer. We are going to have three dimensions. We are going to have an input width, input height, and input depth, and same for the output. And I also haven't said that if we are going to connect two layers, the output size. Okay, when I say output size, I'm meaning the output depth, output width, and output height. So let's say the output size of the previous layer is equal to the input size of the next layer, and obviously the output of the previous layer is the input of the next layer. That's some basic stuff that you need to know. So I've started creating a class layer, and I've also already created a new package tools, and it's very similar to the class network tools that we had in the last tutorial, but I've just added some new methods. For example, we can create random arrays in 3 dimensions, in 2 dimensions and in 1 dimensions. So we need, for example, if we are going to deal with the bias, we are going to need only 1 dimension. This is going to be for I'm actually not quite sure if we are going to need this. Yeah, we might need this someone else. We can randomize 3-dimensional, 2-dimensional, 1-dimensional arrays. So we are going to take an already existing array in here. We're telling it the lower and the upper bound, and every value in the array will get a value in between the lower and the upper bound. And we still have the random values contains value and index of highest value method, and the random value that just returns a random value in between the lower and the upper bound. Also, we can copy an array, and we can convert a flattened array. This is what I just talked about. Like when we are going to deal with the standard feed forward layer, we are going to the input will will be in 3-dimensional array, but usually we want to only work with 1-dimensional arrays in fully connected layers, so we can break that down. So we're going to just remove the when we are talking about fully connected layers, the output values will the first index is the output depth, the second one is the output width, and the third one is the output height. And the size of this array will be 1, 1, and the amount of neons that we want to have, so that we can just convert an output array of a fully connected layer into a single-dimensional array with just taking the array at the index 0 and the index 0. Same goes for we can take a double array and just quickly create a 3-dimensional array by creating a new array out of it and just putting the input array into 2 brackets. So it's at the array at index 0 is the input data. So that's just basic stuff. It can be downloaded in the description. Everything can be downloaded in the description. So let's get started with the layer class. On my left I have the what I'm going to copy, because I've asked you in the last video and you told me that I should do it a little bit quicker. So what I will need is I'm going to need the I'm going to start with the layer. This is a more layer-based approach, not a full network thing approach. So we are going to start with the layer. At the end, we are going to connect layers and create a network out of that. So what we're going to need is we are going to need some variables, and we are going to need the input depth, input width, input height, and the output depth, output width, and output height. Also, we need to know the previous layer, so private layer, pref layer, and private layer, next layer. And also what we need, I've already shown that to you, we need the output values, the output derivative values, and the output error values. And yeah, that's pretty much it. That's all the variables that we need. And we are going to need a constructor. This is like I've been sitting behind this code for like a long time, and I was thinking, how could I make this the most efficient way? And the most efficient way is probably not the most beautiful way. It will get like really complicated maybe. The usage at the end is like really easy, but coding it is like it's not fun. Especially not for beginners. So I assume that you know how Java works, and yeah, the basic approach is that when we are going to build a network, we're just going to add layers, and at the end we are going to connect these layers. So we're just creating a list out of layers that we want to add in any order, and after that, like when I've got all the layers together, I'm going to build the network. And for building the network, we are going to need a method that connects a layer to the previous layer. And for this, I'm going to make a new method, connect to previous layer, layer pref layer. And obviously this, not obviously, but this can throw an exception. You will see later why. So it might happen that, for example, the fully connected layer tries to be connected to a layer where the output is not flattened. When I'm talking about the flattened output, it means that the output depth is equal to 1 and the output width is equal to 1. And the output height can be anything, but it's flattened if the output depth and the output width is equal to 1, so that we can translate the output into a one-dimensional array. So this dot previous layer is equal to previous layer, this dot previous layer dot next layer is this, and then we need to set the input width, input depth, and input height, and this is obviously the previous layer dot output width, output depth, and output height, like this. Also, we need to check if the it might happen that we don't know the output size yet. So for example, there are layers, like the fully connected layer, we already know the output when we are creating the layer. So I'm going to make two new constructors at this point, and one constructor is where we know the output size. In the other one, we don't know the output size. Like it can happen that we only know the output size when we are connected to the previous layer. And we do not know that yet in the constructor because we are just adding layers together in an array. And in the array, they have no idea who they are next to. So we might know the output, we might not know the output. So if we do know the output, this is going to be irrelevant, but I'm going to check if this dot output depth is equal to 0 or any other output size values. And then I'm going to delete this for a second. So if any output size is equal to null, we need to calculate those. And I'm going to make an abstract method. The whole class needs to be abstract. So we're going to create a fully connected layer and whatsoever, and they all need to implement these methods. So I need to create this method, protected abstract void calculate output dimensions. And this happens if we do not know how big the output should be at the beginning when creating the layer itself. So we are just going to know how big it should be when we are connected to the previous layer. So when this method is called, and this only needs to be called if we have used the second constructor. Otherwise, we already know the output size, but it might happen that we don't know the output size. Then, if for some reason this we mess up here, I'm going to throw an exception. So if this output depth is smaller than 1 or anything like that, that means that it doesn't work, because all these values, even if for flattened output or something like that, it needs to be 1. Smaller than 1 just simply doesn't work. You can think of it this way: the total amount of neurons in a layer can be calculated by multiplying the output depth, output height, and output width with each other. If one of these would be 0 or less, like less would be like kind of awkward, I guess. If anything of these is 0, the whole amount of neurons would be 0 as well, and this it just doesn't work for us. Then I'm going to initialize the arrays. Initialize arrays. I'm going to make a new method for that quickly, and I'm calling a method on build. This is for every class that extends this class to like create stuff like the bias, the weights, and whatsoever. Because at this point we know everything. We know the input size, we know the output size, and that's usually everything we need for creating the final layer. Initialize arrays. I'm going to quickly copy this as well. Just like creating the output values, output derivative values, and output error values arrays, or like filling them, not filling them, but like creating the array in here. And on build is something that needs to be implemented by the other classes, public abstract void on build, and this can also throw an exception like this. Okay, this is really good. I'm not sure if you've ever heard about recursion. This is like used in this this will be used in this class, and the idea behind that is that when we are going to feed the data forward, we are going to call from our input layer like the feed forward method, and this one will calculate, like it will do some calculations. Like there's no calculations in the input layer, so this is like there are no calculations in the input layer, but it's going to tell the next layer to do the calculations, and this one will tell the next layer, so that at the end we will have every layer calculated, and this is going to work. So I'm going to make a new method for that, and this one is called public void. I'm actually going to copy this as well. So public void feed for recursive, and obviously for this we need this dot calculate. So we need a way to calculate the output of a layer by taking the input of the previous layer. Public abstract void calculate like this. But also we need to apply the backpropagation algorithm, and we're going to do this in recursion as well. So I'm going to make a new abstract method that needs to be implemented. Public abstract void calculate signal errors. And what this is going to do is, if you have the image of the network in mind, like a layer has the weights to the previous layer, and what a layer knows is the error of its own output, because this one is calculated by the next layer. So each layer is going to calculate the output error of the previous layer. This is very important to know, and this is like one of those things that was really confusing for me when I actually started coding this, and I've messed up a lot of times. But if you think about it, it makes total sense. And if you have any questions about that, just feel free to ask me. So each layer will calculate the output error of the previous layer, because we're backpropagating. So we know the think about the output layer, for example. The output layer knows the output error signal, and then we can, by the output error of the layer before the output layer. No, wait. The error signal of the layer before the output layer has the same error signals as the output layer itself. Therefore, we can calculate the error signs of the previous layer by taking the error signs of the output layer, and then the previous layer can calculate the error signs of the previous layer, and so on. So that's the theory behind that. Also, when you look at the formulas, there's nothing that influences the output error sign at a layer except the output of that layer. So when we have a layer, when we have an error sign at a layer, it is influenced by the output of that neuron, the derivative of the next neon, I think. I'm not, no, wait, the arrow sign of the next layer and the weight. The weight and the arrow sign of the next layer, it's like part of the next layer, and the output can be accessed by the next layer as well. So like it works this way. So we need to make this recursive as well to make things easy. Public void feed forward. No, I'm going to call this feed backward recursive because it's like backwards passing the arrow signal. I haven't shown you this, so feed forward recursive is pretty much just calculating, calling the calculate method, and if the next layer is not equal to null, it's going to call this next layer to feed forward recursive. And if there's like a next layer, the next layer is the first thing it's going to do is it's going to call this calculate, and then it's checking if the next layer can call this calculate, and so on. Feed forward recursive looks pretty much the same, except we are starting at the end. So we will ask if this dot previous layer is not equal to null, and this dot previous layer dot calculate signal errors. Let me quickly check if I'm messed up. No, I didn't. Everything is fine. And of course we need the weights update, and we can make this recursive as well. It doesn't matter if we are running from front to back or from back to front, but in the last tutorial we were running from front to back, and we're going to do the same here. So we can pretty much copy this calculate thing and just rename it to update weights and update weights recursive. I need to put this one here, and it's like this and this, and that's pretty much it for the recursion, and that's like the core. That's like pretty much everything that we need for the layer class. I'm going to add some getters and setters, and also some. So there's some. I've created some useful methods to format an output. For example, I've got a print array method. This one will be fixed soon, so it can print a 3-dimensional array in a really nice way. It's like it's hard to print a 3D array in the console, but this is like a really nice way, and you will see later how it works. Then we need like 2 methods that check if an output array or if a double array matches the output size. So this can be static. This doesn't work yet because we don't have the getters and setters. I'm quickly going to implement the getter and setter methods. Like this getter and setter methods for, let's actually take everything. Like this. But we need to be careful because if we no, we don't want to set the in. Okay, let me do that again. That doesn't make sense. Let's create the getter first. So we want getters for everything, and that's totally fine. But we don't want setters for everything. We need to be careful. We can't set the input width and so on. We could. It doesn't really. We should not change the next layer or previous layer. So we don't need that as well. And we might want to set the output error values, but we need to be careful if the dimensions match. Like we could not set an output array of double values that does not match our output depth, output width, and output height. Therefore, I created this matching dimensions method, which check if the output depth is equal to the values.length, so the length of this array, then the output width needs to be equal to the values at 0.length, and the output height needs to be equal to the values at 0 and at 0.length. That's like how we are checking how big a 3-dimensional array is. We want some setters, so we want to set the output values, output derivative values, and output error signals. But we need to check if this dot matching dimensions of output values, if this is true, then we can actually set this. Otherwise, we are not going to set this because this would mess everything up. We are going to do the same here and same in here, like this, and this should, I think this is it for the layer class, and this is also it for this video. And in the next video, I'm going to I'm probably going to implement the first few layers, and I'm going to show you some functions that we are going to need for the implementation. So go ahead and implement this by yourself if you want. The code can be downloaded in the description, and I hope to see you in the next video.